Hey guys, welcome back to geometry. In this unit, we're going to be focusing on transformations, so we should be sticking with our transformations packet. And we're going to be specifically focusing on reflections for our first day. So this should cover about the first 10 pages of your packet. Just some notes when you're watching this video, I want to just point out a few things. Usually on the bottom left corner of your slides, you're going to see a page number that corresponds to the page number that you should be on in your packet. And so that was just to make it easier for you to follow along. In addition, I wanted to point out some colors that you want to make note of. So whenever you see a bright yellow background, that means that there's new information. Whenever you see a neon green color in the background, that means that you're trying the example on your own. Whenever you see a hot pink color in the background, that means we're at the end of the lesson. You might also see a blue background now and then for like a challenge question, but those challenge questions are not necessary for you to complete. So let's actually go into transformations. So you might have actually covered transformations back in 8th grade, or if you took integrated algebra, where you learn a little bit about geometry when you're in algebra class, you might have covered it then as well. But a transformation of a geometric figure is a change in its position, shape, or size. And we're going to be focusing in the beginning of the unit on changing positions to create congruent figures. And when you assemble a jigsaw puzzle, for example, you often move the puzzle pieces by flipping them, sliding them, or turning them. Whenever we flip an object or a figure, that's a reflection, and that's going to be the transformation that we cover today. So every time you make a move, that's a different type of transformation. And if you look at some of these photos below, you actually see an illustration of some of the transformations that we're going to be covering. So for example, when you see this car, it's being rotated around. So this is an example of a rotation. When you see Capitol Hill being reflected in this body of water, you know that that's going to be a reflection. And then seeing how this person is just moving up and to the right, we know that this is called something called the translation. So why don't we standardize some of the vocabulary that we're going to be using throughout this unit and in later units as well. So the first vocab term that I want to highlight is something called an image. And so an image is the resulting point or set of points under a transformation. So for example, let's look at this point P. If it's being reflected over this line L, P, because this is the point that's having the transformation done onto, this is called the pre-image. And so this is whatever your figure or point is before the transformation. And then this point after the transformation is called your image. So this is after transformation. And we denote this by putting a little apostrophe sign next to the letter of your point. And so we read this as P prime. In addition, another term that I want to highlight is something called an isometry. So an isometry is a transformation that preserves length. And so when I'm talking about length, I really just mean size. So the isometries that we're going to be focusing on in this unit is reflections, translations, and rotations. Those are the three main isometries that we're going to be focusing on. And then finally, we have this term mapping. So a mapping is just an operation that matches each element of a set with another element, its image in the same set. That's a fancy way of saying that something like a translation or a reflection or a rotation is just matching your pre-image to your image point. So it's mapping A to A prime, B to B prime, C to C prime, right? And so a mapping is just kind of telling you what you have to do in order to change your pre-image to your image. This leads us nicely into our last vocab term that we're going to be covering for now, which is called orientation. So orientation refers to the arrangement of points relative to one another after a transformation has occurred. For example, the reference made to the direction traversed clockwise or counterclockwise when traveling around a geometric figure. So for example, we know that this is going to be our pre-image in this figure because we don't have those apostrophe signs next to our vertex names. And so this is our pre-image. And then in this image, which I know based on these prime symbols, right? So let me just label that. This is my image. I notice how originally in my pre-image, my points were going in counterclockwise order. So they were going in the opposite direction of how a clock would normally look like. So if a clock looks like this, counterclockwise is going this way. So we see that we're going from A to B to C in counterclockwise rotation. And then after our reflection, so after our transformation, we notice that our points are going from in clockwise order. So it's going from A prime to B prime to C prime in the opposite direction. So the opposite direction, right? And so because it changes direction in the order of which the points appear, we know that this is actually going to be the opposite orientation. So this represents an opposite orientation. One thing to note, because we're focusing on reflections today, it's always going to be an opposite orientation when you perform a reflection. So let's look at our first example. So the question says, is the transformation an isometry? Do the figures have the same or opposite orientation? So let's look at this. First of all, I know that this is going to be my pre-image and this is going to be my image based on the lack of apostrophes next to the letters. So I know that this is my pre-image. And then this is my image. And so the first question is asking me if this is an isometry. If I actually got a ruler and measured out each side, I would actually see that it's the same length of each side on the image. So I know that this is an isometry. Yes, it's an isometry because the size is preserved. Size is same. There we go. Now to answer the second question, I want to look at the orientation of points in my pre-image. So to get from A to B and B to C, C to D, we're going in this direction, right? And so when I think about a clock, I know that when I have a clock, it turns in that direction. And so that's clockwise, right? So this is clockwise. Now I want to look at the order of points in my image. So I want to see if the order of points is going to be clockwise or counterclockwise to determine whether or not it's same or opposite orientation. And when I look at my order of points from A prime to B prime to C prime to D prime, I notice I'm actually going in the opposite direction. I'm going counterclockwise. And so because I'm changing the orientation of which I write my points, right, it's actually going to be opposite orientation because it changes from going clockwise to counterclockwise. Let's try out example 2. So in example 2, the first thing that I want to see is if the transformation represents an isometry. And then once again, if I actually took a ruler out to measure each side of my my pre-image and my image, then I would actually see that they're exactly the same size. So I know that this is, once again, an isometry because size is preserved or is the same. I'm going to do the same thing that I did last time where I label my pre-image and my image. And so I know that triangle ABC is my pre-image because of my lack of prime symbols. And then this is my image triangle A prime, B prime, C prime because of those prime symbols. Now I want to look and see what the orientation is for my points being listed. And so if I look at this, I see that I'm going counterclockwise. If I think about a clock, going in the opposite direction means counterclockwise. So my pre-image is moving counterclockwise to go through the points. Now, if I look at my image, right, I want to see how am I moving from A prime to B prime to C prime. And I notice that I'm still moving in the same orientation, right? I'm still going counterclockwise. And so this is also counterclockwise. So this is going to be same orientation because we're still moving counterclockwise to get through all the points. As I mentioned before, we're going to be focusing on reflections as our transformation today. And so going into what a reflection is, a reflection, or sometimes you might call it a flip in certain textbooks, is an isometry in which a figure and its image have opposite orientations, just like we said. So we just covered what an opposite orientation meant. So this means if your figure, if your pre-image is going clockwise, then your image would be going counterclockwise and vice versa. Thus, a reflected image in a mirror appears backwards, right? And so whenever we're creating reflections, we want to think about how would it look if we just place a mirror right in front of it, and what would the mirror image look like? That's what we're creating when we're creating reflections. So whenever we're creating reflections, we want to note that every point is the same distance from the central line. And the central line is just telling us where we're reflecting from. So if we're holding up that mirror against the image to create its mirror image, right? Where we place the mirror is going to be our central line. In addition, the reflection has the same size as the original image, and so this means that this is an isometry, and we noted that before in our definition of what a reflection was. So looking over here, right, we see that this is our pre-image, this is our image based on those symbols, and it looks like we're reflecting across this line over here, and this line actually is the x-axis. Right. So something I just want to note is it's helpful before you go into your examples to just kind of see what kind of patterns going on. So if I'm comparing the coordinates for A and A prime, I notice that my y's become negative, but my x's remain the same, right? And so this means that you're really going from the top two quadrants of your coordinate plane to the bottom two quadrants of your coordinate plane, where your y's will always be negative, right? And so this is why the general rule when you're flipping over the x-axis is to keep your x the same, just change your y. So let's actually go into a couple examples where we do that. So let's try out the first example where we're going to actually reflect our triangle over the x-axis. So before we get started, why don't we actually draw out this triangle that they list for us? So I'm going to plot each of these points and make sure that I label all of those points as well. So just so I know exactly which triangle I'm talking about, my pre-image triangle is going to be blue. So my first point is 2, 2. This is A. B is 3, -5. And then C is -1, 0. So I'm just going to draw my line through those points. And so I've just created a triangle ABC. And I want to reflect across the x-axis. So if I'm reflecting across the x-axis, I want to just make sure that I know that the distance between my central line and my pre-image point is going to be the same as the distance between my central line and my image point. So if I'm looking at A over here, right, I know that A prime is 2 away from my central line, which is my x-axis. So it's 2 up from my central line. So I'm just going to move 2 down from my central line to create my reflection point. So this is going to be A prime. And so that is going to be 2, -2. If I look at B, right, I see that B is 1, 2, 3, 4, 5 away from my central line, going down. And so in order to create my reflected point, I want to go 5 up from my central line. And that's going to be right over here. And so this is going to be B prime. And so that coordinate is 3, positive 5. And then finally, I see that C is actually on my central line. And so I'm not going to actually move my point C. I'm going to keep it right over here. So this is also C prime. And if I just connect those dots, and I fill in what my coordinate is for C prime, I've just reflected my triangle over the x-axis. And so the rule, it seems, is to keep the x, so keep it, whoops, and just change the sign for the y, so change it to negative y. Let's try out reflecting over the y-axis, right? So first things first, I'm going to just plot my points for my pre-image triangle. So A is 1, 3. As I'm plotting my points, just to keep things easy for me, I'm going to actually label these points. My next point is negative 2, 6. So this is point B. And then finally, C is 0, 0. Okay. And so let me just label that as blue. And now I'm being asked to reflect over my y-axis. And so my y-axis is the one going up and down. And I want to make sure that wherever my pre-image point is, it's going to be the same distance from the central line as my image point is from the central line. So if I'm looking at A, right, I know that it's just 1 unit away from my central line. And so I'm just going to go 1 unit away from my central line in the opposite direction, and that's going to be my A prime. If I'm looking at B, right, B is 2 units away from my central line. So staying on that same y value, I'm going to move 2 units away from my central line in the opposite direction. So this is where my B prime should be. And then finally, for C, I know that C is on my central line, which is this y-axis, so it doesn't actually move anywhere. It's going to stay the same. So this is also C prime. If I just connect the dots, I've created my reflected image. And so these points are, let's see, negative 1, 3, 2, 6, and 0, 0. And it looks like the only thing that changed was changing the sign of the x value, but we kept the y values the same. And so our rule for this is just going to be negative x, y. So it's the opposite for the x-axis. Let's go over these different reflections, right? So for number 3, once again, we just want to actually first draw our pre-image triangle. So triangle ABC. So I'm going to do that in blue, like how we've been doing before. So my first point is 0, 0. I'm going to label that 5, 2. Whoops, I'm going to label that as B. And then finally, 4, 4 is C. So I'm going to draw these 3 points together. Now it says to reflect over the line y equals x, right? And so if I actually graph this line, y equals x, let me graph it in green. Y equals x is this straight line right over here. And I know that just, from graphing linear equations, my slope is just 1, my y-intercept is 0, so I just go up 1 over 1, up 1 over 1 from the origin. Now, to actually graph my reflection points, right, I actually noticed a couple things. So A, my pre-image point A and my pre-image point C, they're actually on the central line. And so if I'm just thinking back at my previous examples, where if my pre-image point was on the central line, my image point was actually going to remain the same. So I know that for A prime and C prime, they're actually going to be the same points as A and C. So A prime is 0, 0, and so is C prime is 4, 4. So I'm just going to graph those right on there. Now B is where it gets a little bit tricky. right? So I'm just going to use C as my point of reference to see where to graph B prime, right? So to get from C to B, right, since C is on the central line, I had to go down two to the right one. Now, I'm going to just reverse that, right? So to get B, I went down two to the right one. Now I'm just going to kind of flip that, right? So I'm going to go up one and then to the left two. Okay, so I not only reversed these directions, but then I also flipped these numbers, right? So from C prime, I'm going to go up one to the left two. And then this is going to lead me to my B prime. So this point is B prime. So now I can actually connect my points. And it seems like my point for B prime was 2, 5. Okay, so when I look at how these points differ, right, I notice that A and A prime and C prime were the same. So I'm really just going to look at B and B prime to kind of compare what I should be doing as my rule for when I'm reflecting over y equals x. I notice that these values are exactly the same. They're just flipped, right? And so in order to flip them, instead of my coordinate being xy, when I reflect over y equals x, it's going to be y comma x. And that's going to be my rule. Let's try out example number 4, right? So once again, it gives us our pre-image triangle. So let's just graph that first. And so I'm first going to graph A as 2, 2 and label that. B as 6, 2. B, and then my last one is 4, 7. And that's going to be my C. I'm just going to draw my points through those. And it's asking me to reflect over the line y equals negative x. So let me just draw y equals negative x so I know what I'm looking for. And so I know that y equals negative x. Let's see, it's right over there, right? And we want to make sure that we're reflecting everything over. So if I'm looking at A, in order to get A prime, I need to look at how I compare to being, how far away I am from the central line, right? So I see that I'm diagonally 2 across from the central line for A. So my A prime is going to be diagonally 2 across from the central line in the opposite direction. So this is actually going to be my A prime. So let me just put that point there. This is my A prime. And so that point is negative 2, negative 2. Let's look at how to find where B prime is going to be. So if I look at my pre-image point B, right over here, let's see how it compares in location to the central line. So I see to get to B, let me just go from this point on my central line. Actually, let me go from this point on my central line. I see that I'm going 2 to the right, and then 1, 2, 3, 4, 5, 6. Okay, so I picked a point on my central line, and I realized I had to go 2 to the right and up 6 to get to my pre-image point. So to get to my image point, I'm going to do the opposite. So if I went 2 to the right and 6 up, then I'm going to do 6 left and then 2 down. So let me just find that point again. So it was right over here. And so I'm going to go 6 left. So 1, 2, 3, 4, 5, 6, and then 2 down. 1, 2. And this is going to be my new point for B prime. And so that coordinate is negative 2, negative 6. So let's actually figure out where our image point C prime is going to be. So I want to just pick a point on my central line and just see how C compares in position to the central line. So I'm just going to pick this point, and let me just highlight it so I know exactly, and I can keep track of that. So let's say that this is the point that I'm going to be referencing on my central line. So if I'm looking at C from this point on my central line, I notice that I'm going 1, 2, 3, 4, 5, 6 to the right. So let me just write that. I'm going 6 to the right. And then after I go 6 to the right, I'm going to go 1, 2, 3, 4, 5 up. 5 up. And so now I just want to flip those numbers. So I'm going to do 5, 6, and then flip these directions. So instead of going right, I'm going to go to the left. And instead of going up, I'm going to go down. So to get my C prime from that reference point on my central line, I'm going to go 5 to the left. So 1, 2, 3, 4, 5. And I'm going to go 6 down. So 1, 2, 3, 4, 5, 6. And this should be where my C prime is. Right, and then I can actually just draw my lines through my points. And that coordinate is, what is that? -7, -4. Okay, so I'm actually noticing that whenever I am reflecting over this line y equals -x, my points are actually flipping. So my x and y are changing position, and they're both actually changing sign. So if they were positive, then they're going to become negative. So my rule is actually going to be flipping the x and y. So this is going to be y first and x second. And then changing the sign for y and x. So this is going to be negative, this is going to be negative. And we've created a rule for when y equals -x. So because the background of the slide is neon green, you are actually going to try these problems on your own. And so you're just going to pause the video here and try to figure out where the new point locations are going to be. You can use the rules that we've created just as a shortcut so you can finish your problems as soon as possible. However, based on my experience in teaching geometry, I find that it's actually not super helpful to remember the rules just because it's very easy to forget them or get them mixed up. So before you go into these Regents questions, I really recommend that you go back to the previous examples and just kind of understand a little bit more where these rules were coming from. Because if you don't understand where the rules are coming from, then the rules aren't really going to make sense and they're not going to stick. So just pause the video here, and then when you're ready to check your answers, press play. You ready to check your answers? Let's go over them together. So our first question is asking us, point A is located at 4, -7. The point is reflected in the x-axis. So that's what I really want to focus on when we're reflecting over the x-axis, right? And so just to speed things along, my rule for reflecting over the x-axis was we keep the x the same, we just change the sign for y. So if our pre-image A was 4, -7, my image A prime is going to be, I'm going to keep the x and then just change the sign for my y. So because my y was originally -7, if I change it to the opposite sign, it's going to be +7. So this is going to be my point A prime. Let's try out number 6. So it says, what is the image of the point 2, -3 after transformation R over the y-axis? So we're reflecting over the y-axis. So let me just highlight that. My point is 2, -3. I'm not given a name for the point, so I'm just going to name it P. So this is P is 2, -3. And my rule for the y-axis, so rule y-axis, was I just change the sign for my x coordinate, so it changes to the opposite sign, but I keep the y the same. And so if my P was 2, -3, my P prime is going to be, I'm going to change the sign for my x coordinate. So if my x coordinate was originally 2, it's going to become -2, and I keep the y the same, so this stays as -3. Let's move on to number 7. It says, what is the image of 5, -2 under the transformation of a reflection over y equals x? So once again, I just want to highlight that I'm doing a transformation of a reflection over the line y equals x, and my original point is 5, -2. Once again, I don't have a name for this point, so I'm just going to call it P. And if we remember in our last example, our rule for when y equals x was we just flip the y and the x. So it's y comma x. So my p prime is going to be a result of just flipping my x and y coordinate. So it's going to be -2 comma 5. And that's going to be the image point. And then finally for number 8, our rule was after we reflected over the line y equals -x for this point 5 comma 2. Okay. My rule was flip it and negate it. So it was going to be -y over comma -x. So my p prime is going to be a result of me flipping these two coordinates, right? So 2 becomes my x, 5 becomes my y, and I'm going to negate both of them. So this should be my image point. On the geometry regions, we're usually asked to take it one step further. So we're not just reflecting on axes or a simple line like y equals x or y equals -x. Sometimes we're asked to reflect on a central line that's kind of random. And so whenever we're reflecting over vertical or horizontal lines that they give us, we want to make sure that we're referencing back to what we remember in our unit 1 when we talked about midpoints, because that's actually going to be super helpful when we're actually trying to find where our image points should go. So before we get started, just like how we usually do, we want to actually just graph our pre-image triangle, and then we also want to graph our central line. Okay, so if I'm graphing my pre-image triangle, I'm just going to plot these points. I have A is -4 comma 1. So when I plot the point, I remember to also label the point just for ease in the future. My B is -1 comma 1. So this is B. And then my C is -3 comma 4. And then I'm just going to connect those points. And that's my triangle. Great. So I need to reflect over this central line y equals -3. So remember, whenever I have an equation of y equals and it's a constant, then it's just going to be a horizontal line through that y value. So I'm going to draw this line y equals -3 as a horizontal line through the y value -3. That's probably as straight as it's going to get. So we need to actually figure out where our image points are going to go now based on the central line and our pre-image. And so I drew a y equals a horizontal line, right? And if we think back to when we were flipping over another horizontal line, like the x-axis, we actually kept our x's the same, right? We just changed the y's. And it's the same kind of concept when we're flipping over a different horizontal line like y equals -3. Our x's are going to remain the same. We're just flipping the y's, right? So when we're thinking about our x coordinates for our image points, it's actually going to be the same or constant as the pre-image x coordinate points. So this remains the same. So this is going to stay as -4. This is going to stay as -1. And this is going to stay as -3. Okay, so we already have those points figured out. Now we need to figure out what our y coordinates are going to be, because that's what's really going to be changing. Now, I actually want to just think about what is the distance between my pre-image point and my central line, and then I'm going to just continue that distance on because the central line is serving as my midpoint. So if I'm looking at my pre-image point A, if I'm trying to see how far away it is from the central line, I see that it's 1, 2, 3, 4 away from my central line. So I went down 4, subtracted 4 to get to -3, right? And so I just want to, once again, subtract another 4 to figure out what my y value is going to be for my image point from the central line. So from -3, I'm going to subtract -4 to get -7. And then that should be my image point A prime. So I'm going to plot that and label it. So this is -4, -7. I'm going to do the same thing for B, right? I know that I'm trying to get from 1 to -3, which is the y value for my central line. So that's another subtracting 4. And if I subtracted 4 to get from my pre-image to my central line, I'm going to subtract 4 from my central line to get to my image point. And so that's going to be -7. And so that's my next point, -1, -7. I'm going to plot it as B prime. And then finally, to get from 4 to -3, I subtracted 7. And so to get from my central line to my image point, I need to subtract another 7. And so that's going to be -10. And so C is going to be -3, -10, which is right over here. And this is my C prime. And I just successfully flipped it over that y equals -3 line. And so my image points are going to be -4, -7, -1, -7, and then -3, -10. So in our next example, problem number 10, we're given a triangle once again, and we're given a different type of reflection. Remember, whenever our equation is x equals a constant number, it's going to be a vertical line, right? And so the first thing I'm going to do is just draw out my pre-image triangle. And then I'm going to graph out my central line using this green color. So let's first plot our points for our pre-image triangle. So our pre-image triangle is going to be A is at 2, 3, just right here. B is at 5, 6. So 5, 6 is right here. And then C is at 8, 4. Just going to connect those points. And I just drew my pre-image triangle. Let's move on to our reflection line or our central line. And it's x equals -1. So this means that when your x value is -1, you're just going to draw a vertical line through that x value. And so my central line is going to be right here. That's pretty straight. Great. And so I want to do the same kind of thing where I want to think about the midpoint again, right? And similar to when we were flipping over another vertical line, our y-axis, right? We noticed that we actually changed the x, but we kept the y exactly the same. So when we're thinking about how our y's are going to change, they're actually not. They're going to remain the same in our image points as our pre-image points. So if 3 was our y coordinate for our pre-image, 3 is going to be our y coordinate for our image. Same thing for B and B prime, and C and C prime. So we're actually just changing the x's. Now, we know that our x in our central line is -1. And so we want to think, how did we get from our original x value 2 to -1? The reason why we're thinking about this is because we want to think about the distance between our pre-image point to our central line. And whatever that distance is, we know that we have to move the same distance to get from our central line to our image point. So let me just move this over so I have a little bit more space. So to get from 2 to -1, I know that I have to actually subtract 3. So my distance between my pre-image point and my central line is -3. So whatever that distance is, I need to copy that from my central line to my image point in order to get my coordinate for my image point, right? So I need to do -1 minus 3, that gives us a -4, and that's my first coordinate, -4, 3 for A prime. I need to do the same thing for B to B prime and C to C prime. So to get from 5 to -1, our pre-image to our central line, we have to subtract 6. So I have to subtract 6 once again to get from my central line to my image point. So this should be -7, 6. And then finally, for C to C prime, whoops, let me just write this down. From C to C prime, I need to subtract 9 to get from my pre-image to my central line. So to get from my central line to my image point, I need to subtract 9 again. So that gives us -10, 4. And let's just plot these points. So I have -4, 3 as my A prime, -7, 6. So -7, 6 is my B prime. and then C prime is negative 10 comma 4. And once I connect these lines, I have my reflected image. So let's say that I'm actually just given an image and a pre-image, and I need to find out what that rule is to describe the transformation that happened. So I know that both of these are going to be reflections because I see that just the orientation has just flipped. So for number 11, this is a reflection. Number 12, this is also a reflection. I need to figure out what type of reflection it is and where the central line is, right? So the way that I do this is I just pick an image point and a pre-image point. So just for ease of access, I'm just going to pick E and E prime. So let me just highlight those. I'm focusing on E and E prime. So because I'm focusing on E and E prime, I actually want to see the distance between those 2 points, between the pre-image and the image. So I count 1, 2, 3, 4, 5, 6, 7, 8. E and E prime are 8 units apart from each other. So let me just label that. They are 8 units apart. Okay, and because I know that I want to reflect the same distance, so my pre-image point and my image point are going to be the same distance apart from the central line, I need to figure out what's between E and E prime. And so I want to take that distance between them and just divide it in half. And so I know that the central line is going to be halfway through 8, which is 4 units apart from either of those image or pre-image points. Oh, sorry, pre-image or image points. And so I'm just going to take my pre-image point and just count 4 units apart. So 1, 2, 3, 4, and it's going to be that point right over there. Well, I noticed something, right? That this point is actually on the x-axis. And so I can say with a good amount of confidence that my reflection line, my central line, is going to be the x-axis. So the way that I would write this is that I am reflecting R over the x-axis. Let me try out the same thing for number 12, right? It doesn't state which one's my image and which one's my pre-image. So I'm just going to say that the one on the left is my pre-image and the one on the right is my image. Now, I know once again that this is a reflection because they're just flipped over each other. And this could have been like, a combination of transformations, but let's see if we can just find a transformation only using reflection. Okay, so I want to just pick a pre-image point and an image point just to compare. And so I'm just going to focus on these two. So let me just highlight those, focusing on this point and this point. And I want to see the distance between these two. So I'm going to count 1, 2, 3, 4, 5, 6. They're 6 units apart from each other, so let me just label that. And so I know that my central line is going to be at the midpoint or in the middle of the distance between those 2 pre-image and image points. So I want to think what's halfway between 6 units apart, and that's going to be 3 units apart. So I'm going to start from my pre-image point and move 3 units. So 1, 2, 3. And this is where my central line should be. Okay. Now, if I'm thinking about whether or not this is going to be a horizontal flip or a vertical flip, if this were a horizontal flip over this y equals 4, my image point would actually be up here, but it's not. It's over here, right? So it's not going to be flipped over this horizontal line that's going through this point. It's actually going to be flipped through this vertical line going through this point, because if I take this and just flip it over this vertical line, it should end up looking like this. So I know that it's actually going to be an x equals equation, not a y equals equation. And I just want to take a look at what this x value is over here. I see that it's going to be x equals 2. So my reflection is actually going to be r reflection over the line x equals 2. So on page 6 of your packet, you have a challenge question. I'm not going to go over the answer. If you want to do it for extra credit, you can just email me and I will check your answer for you. But if we move on to page 7, we actually have a summary of everything that we've covered. So whenever we're reflecting over the x-axis, we can use this coordinate rule, x comma negative y, to get our new points. Same thing with y-axis, we can just negate the x and then keep the y the same. And then if you're reflecting over a very common line like y equals x or y equals negative x, then you have these coordinate rules that you can rely on. But then the biggest thing is just you want to make sure that your distance between your preimage and the central line to the image is the same. And so you might not actually need these rules if you just understand that concept deeply and understand, where these rules are coming from, because that's probably going to help you in the future more than just, remembering which one is negative, which one's positive, which one's getting flipped. So to just, finish off this lesson, we have an exit ticket, right? So take a minute to just pause the video here and work on these 2 questions to assess your understanding of the material that we covered today. And when you're ready to go over your exit ticket, press play. All right, you finished your exit ticket. Why don't we go over it together? So it says, what is the reflection image of 5, negative 3 in the y-axis, right? And you can just graph this and then, use your intuitive understanding of the pre-image being the same distance away from the central line as the image is from the central line, but I'm just going to use the coordinate rule just for ease of access. So my pre-image point is 5, negative 3. So let me just highlight that. And my coordinate rule for when I'm reflecting over the y-axis is my x becomes negated, but my y stays the same. So let's actually apply that rule. So let me change the color. Okay, so I'm going to just negate the x. So this becomes negative 5, and I keep the y the same. So then my reflection image point would be negative 5, negative 3, which is option C. For the second question, it says, what is the reflection image of 5, negative 3 in the line y equals negative x? If I'm thinking about my coordinate rule for y equals negative x, I know that I switch x and y, and I negate them. So I need to flip negative 3 and negative 5 and positive 5. So negative 3, positive 5. And I want to negate both the x and the y coordinate now. So I'm going to change the sign for negative 3 to positive 3 and negative 5 to, positive 5 to negative 5. And so the answer that matches this is H. So for the day 1 assignment, you want to work on pages 8 through 10 for your homework. You should be able to do all of these, and if you're having any problems with them, just feel free to call me or email me. And good luck.